Let's just jump in and wire this thing in and play with it. What do you say? Hey everybody, welcome back to the garage, and we're 99% done with the wiring for the most part. Reminds me I need to go ahead and hook up my barometric pressure sensor. I've got to figure out a mount for this thing, but might as well plug it in because we're getting ready to power this thing up. And yeah, jump into the software side of things. We've got a couple small wires to take care of here. Here, there, you know, we got to find ignition voltage. I believe the car is ready to have voltage turned back on. I've got the power switch shut off back there, but I got a couple things that we probably need to go over whenever we're doing this. We've got the primary stuff on all the engine bay done, so our power should be coming in. We just got to find our ignition power. We'll dive into that spare harness here in a second. Make sure you have your tools ready. But grab a couple extra things. Now, this is optional. I've got what we used to call a Fox and Hound. It's essentially a tone generator that you can put on wire. You can put one side on wire and the other side on ground, and it helps to find wires quickly, especially in vehicles that you don't know what all is being used. I spent yesterday probably jerking so much wire out behind the dash that didn't need to be used. Top of it, went ahead and got a wiring diagram specific to this car. This has an upgraded harness in it, so this not the most helpful. Probably going to need a meter also, but instead of a meter, since we're actually putting voltage on, I'm just going to use a simple test light. So it makes it a lot easier. Just hook it to ground and I can probe if I'm looking for voltage. Now, if I'm not looking for voltage, then I'll break out the multimeter so we can find what we need on there. But let's, I guess, actually, let me turn the power on. Let's see if smoke comes out of anything. Let me find a fire extinguisher. Okay, brand new fire extinguisher. Where are all the other ones at? Oh, there's literally one right here on the wall. Okay, I knew that after I'd lit the Super-Auto on fire that I'd hung multiple fire extinguishers in here. Okay, we got two. Hopefully we don't need any of them, but let's just turn our power on, see what happens. Okay, not seeing any smoke yet. And I know we've got power on because the dome light in this works. This might be the first old car that I have that the dome light actually works in. So that's a good sign so far. Let me move the camera over so we can see inside the car, and then we'll dive into that side of it. Okay, oh, can I get in? Can you see me? Okay. We got a lot going on, and you probably can't see all of it over on this side. These are a lot of spare wires. Some of these, like this one, might be hot right now. So I'm gonna go ahead and hook up my test light and make sure I don't have any hot wires just floating around, not doing anything. Okay, that's not. So I have a sneaking suspicion. Pink is generally gonna be voltage on these and ignition. So this one should be on our ignition switch. We can test that out real quick. Yep, so you can see that that is 12 volt ignition power. We're going to need one of those. It's interesting. What's that sound I'm hearing? Relays. Okay, just relays. We're going to need one of those specifically because here's our flying leads. So let's talk about what we do and don't need. Brake switch, we don't need in this situation on the core side. So that one, poop. Don't care about that because we're not using the core for transmission control. What we got here, check engine light. That will be utilized later. Whenever we put our Dakota digitals in, we can run that over to our Dakota digital input box, and there will be a check light on the actual dash that we can use. Engine speed, we're not going to need that one ever. That's an output. We could use that to go over to Dakota Digital as the output, but honestly, whenever it comes to using the Dakota Digitals, we're going to try, same thing with the check engine light, we're going to try and do all that over CAN bus. So this should be fan 1, we'll eventually use that. Vehicle speed, I don't think we need vehicle speed, and I don't remember if this is an input or an output, so that may be a calculated output for the speedo. Here's probably the important one. Ignition key, switch. Then we got our fuel pump relay, which we're not worried about right now. And then we've got our other fan. So these are the 4 wires that I'm most concerned with. These other 4, I'm going to go ahead and cut these off at the tip so there's no bare wires sticking out. Gotta be aware, there's our neutral safety switch. One of those will have power on it because it's well, that'll only be in crank, I guess. Then what is this green wire? Backup light switch. That'll go to the transmission controller. So some of these will go over to our turbolamic whenever we're ending up doing that. But as I said, let me cut these down. Oh, there's my nippers. And I'm just trying to mitigate shorting any of these out for right now. Get them out of the way so we can hook things up. And then we'll go ahead for now, temporarily use this ignition power. It's got a connector on the end of it. Let me find one that'll fit that. And then we should be able to hook it up. Couldn't find a small enough spade connector, so I'm just going to throw a butt splice on here for right now. This will not be permanent wiring. And as you can see, this is long enough to go anywhere that we're going to need to whenever we get to that point. I had to go up to the office to get the one type of cable that I did not have down here, which is an Ethernet cable. That's what we use to interface with. Oh, I should probably go ahead and hook up our drive-by-wire pedal real quick just so it doesn't air out. Okay. Then we can hook up our cord. Now these plugs are only going to go in one spot, so not super concerned about getting these mixed up. Oh, upside down. Flip her over. Okay, there we go. So now we switch over. Here's our Ethernet extension. This is where we're going to plug into and program from. And the nice thing about it is got a nice long Ethernet cable, so we can do this without having to sit in the car. Keep an eye on our voltages. We want to make sure that our voltage doesn't sag. We're not trying to crank anything today. We're just diving into the software. We'll go through the registration or unlocking process and loading the tune into this, and then kind of walk through some of the tune stuff. So let's jump over to the laptop. Okay, so I'm clearly an idiot. I tried multiple different cables, as you could see here. I'm thinking, maybe I bought a cheap USB-C to Ethernet connector off Amazon, thought maybe that was the problem. No, I just forgotten to connect the main grounds. And the reason why is that they are designed to go on the back side of the motor, and with the transmission out of it, the motor was leaned back. There was no way to get a hand back in there. Now the transmission's in there. I can't reach the back side of the motor because it's up on jack stands. So I just connected them to the side of the head, the passenger side of the head. And I don't know if you'll be able to tell, but we have an active light here. So starting over, basically we run the latest version of VCM Live. We double check, we hit the about here, checks for updates, no updates found, good to go. And then what we're going to do is we can open up this folder, and it's going to have some folders underneath it that has some basic tune files. So if you're running a 4L60 or 4L80, you would go there. We're running a 7 HP 80, 8 HP 70, an 8 HP 70. It's going to be considered a manual transmission for our case. Essentially what it means is we're not using any of the transmission control in the controller itself, in the core itself. Now that we know that, we've got a couple different options. Drive-by cable, DBC, 24X and 58X, and then drive-by-wire, 24 and 58. So 24 versus 58 is going to be based on what generation you are. If you're a Generation 3 LS, you're going to be a 24X. That means you're 24X on the crank, 1X on the cam. If you're a 4th generation, you're going to be 58X, which means 58 pulses on the crank and 4 on the cam. So we're going to be drive-by-wire, because that's what you guys voted on. Even though I had a sweet drive-by cable setup, we went drive-by-wire, 58X, and then we've got our base with LS3 injectors, which is nice because that's literally what we're running, so I don't even have to worry about adjusting the injector stuff. But we'll talk about that at some point in time. So now that this base file is open, we should be able to click this button and connect and walk through the registration process. Okay, here it is. Boo, boo, boo. Yes, 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 read. I accept. Oh, it's not going to let me do it until I get all the way to the bottom. And the EULA, End User License Agreement, I accept. Okay. Kyle Crawford, that's me, info@goatropegarage.com. Oh wait, this is my company name. Help if I read, Goat Rope Garage. info@goatropegarage.com. And I'm not sure why it needs this, but manual. Oh, okay, okay. We'll just say motorsport. I don't understand the vehicle usage. Maybe they need to clarify what that is about. So drag would be drag racing, obviously. Race, I'm guessing, is track racing, you know, SCCA, autocross, motorsport. Yeah, just give me motorsport. Okay, so supposedly it's going to email it to me. I'll check my email. So let's open this email and we'll go from here. Actually, I'm not going to let you guys see this because this is my activation key. Probably doesn't matter, honestly. And we just paste it in there, big long, and then unlock. ECU unlocked, okay. So, right away, it's error, number of data points per second is above the limit. Try to change the frequency from measurements before starting to log again. So what do we do now? We just flash it in, right entire. I mean, we haven't configured anything. Executing a right entire will rewrite all data from the ECU. Yeah, let's go ahead. Because we don't actually have a tune file in there yet, so let's just write entire and send it. Okay, complete. Well, I wonder what in the world that was. Oh, that was a throttle body opening and closing. Okay. So we got some DTCs. Mass airflow circuit low. That's fine. We don't have that. Intake air circuit high. We need to check that one. Engine coolant's not hooked up and oil pressure is not hooked up. So honestly, not that many errors right off the bat. So let's do this. Let's go into our setup wizard. No, maybe it is this one. Okay. Okay, here's where it's asking for all of our different stuff. So map sensor, we're running 1 bar. Mass airflow, none. Engine coolant temp, we'll say it's just an LS sensor. Intake temp. GM screw-in style, drive-by-wire throttle body. This is an LS3 style. I like that it actually has, well, there's a Nick Williams one too. We'll just put that one in. That's going to be closer to what we're actually running. I like that it not only has the part numbers, but it also has a descriptor, because some standalones like to just put part numbers in and then you're like, wait a second. I think we've got one of the early ones. We'll double check that as we go. And then if we have any generics, oh yeah, we're actually running a Rife manifold. I guess we'd want that on intake temperature. It's a Rife standard air temperature. Okay. Yes. So let's go ahead and save this as Camaro starting point. Open a new tube file. We'll disconnect. Yeah, that's fine. Okay, so we'll go ahead and reconnect. Yeah, I know. Let's write this in. We should hear it cycle the throttle body again whenever it's done writing. There it goes. Okay. It's a good sign. At least I got the throttle body working right. At least I didn't mess that up. Let's try and get rid of this error, number of data points per second. So we'll come under logging. I've got so many tabs up here that we don't need that I could probably thin these out. There's got to be a quicker way of doing this though. Scan change. Ah, here we go. Data log points per second, 6144 limit 5,000. Look at all these channels that we probably, okay, so can we just delete straight from here? No. So where is this at? You guys are learning with me. You would think it'd be under logging, but it's not. Let's get rid of some of these tabs. Let's delete that one. Default layouts, advanced. That's what we've got open, right? Yeah, okay. We've got all those tabs open. So what about standalone logging configuration? Okay, that is not set up, so that's not part of it. So even though some of these are not, I don't care about, do I just need to go through, how come I can't delete these? Add new channel. I don't want to add, I want to delete. Delete, backspace, nope. Can I select multiple? Yeah. Okay. Okay, so I can change multiple at least at a time. So we've got to get some of these down. Okay, so mass airflow, like mass airflow shouldn't be in. If we come back over to sensor setup or no. Okay, let's just do first time drive-by-wire. Let's figure this out. So accelerator pedal position 1 and 2, yes. Barometric pressure, yes. Engine coolant temp, yes. Intake temp, manifold temp, mass airflow, no. Oil pressure, yes. Okay. So that should take that one out. Let's go ahead and write that. It's really interesting that we just can't delete straight from the log, and why are we not writing now? Oh, that stupid error keeps on coming up. So we're going to have to take care of that error sooner than later, because it's very unhappy about that. Okay, there we go. Said it failed, but it didn't. It just, you heard it do its thing. Okay, let's just control. Let's just slow all these down. Let's just highlight all of them, and we'll take it out to 100 milliseconds. Okay, so now we're perfectly good. 3110, we should no longer get that error. Then if we need to, we can come back in here and fart around with all that. So we'll check our DTCs. We no longer have our math one, but as you see, we now have our barometric pressure, which is perfectly fine. May have to change the scale on that. So if we click this, what happens? There we go. Okay, so now we're seeing live values. That's what I was expecting. Come back under here. This is drive-by-wire. This shows us some of our stuff. Our system setup here. Engine cylinder count 8, 6.2, 0 offset. This stuff we should be able to leave alone. Now, fitted sensors, we can double check this. We don't have an AC pressure sensor or temperature sensor that we're going to be hooking in. Flex fuel, no. Right now, what are these? First stage fan fitted, yes. Question is whether or not we want to run a second stage fan, but we've got it set up for now. And vehicle speed sensor fitted, no. Oh, don't have the lambda sensors hooked up, so those are flagged right now. I'm surprised those don't trigger DTCs. That the lambdas are not reading right. I think that would. Okay, go over to sensor setup. Here is our scaling. Odd that we have knock start window at top dead center, stop window at top dead center. That may have to be populated by actually running the car. But here's all of our offsets and slopes. And so this uses an offset and slope style setup. Essentially what we're looking at as offset is the 0 reading. So these sensors are going to read in 1 to 5 volts, most of them. And you're going to be at 1 volt, give or take, should be around 0, right? Now, if at 0 it's not reading 0, we have an offset that we can adjust to get that 0 there. Then the slope is going to be how much it is per volt. So in this case, our front brake pressure, that's a terrible example. Let's look, our manifold air pressure slope is 18.89 kPa. It's a 1 bar. And it says that at 1, we're offset by 10.33, but essentially every volt is equal to 18.89. You get to 5 volts, and that's whenever you get 100 kPa on there. So we can, this is here, this is not where we necessarily want to look at. This is all the slope stuff. Let's come under logging and look. And so there's our barometric pressure. It's reading 101.28. That's pretty darn close. I'm fine with that. In fact, I don't know why that would be giving us a DTC. Scaled min, below scaled min threshold. So there is a DTC limits here. Barometric pressure sensor DTC P1228. Is that the one that we're getting? P1228. So it says it's below 60, even though we know it's not. I wonder why that's not clearing then. I mean, all the other ones I understand, but that one should be working perfectly fine. Minimum. I'm just going to set that to 1 kPa for now. Let's go back to logging. Kind of take a look at ETC and IAT. IAT is hooked up, but it may not be wired right. That's one of them that I did talk about that we would have to do some troubleshoot on the wiring. So battery voltage coming in fine. Manifold relative pressure, our map is at -20. That is totally wrong. So we can come back into our setup point and look at our map. And I must not have a 3-bar. Let me see. See if I can find a part number that matches. I don't even know what this is out of, to be honest. 261. The one that starts with, nope. This is an AC Delco unit, 555-73248. None of these part numbers are going to match up, but let me try a 2-bar, see what happens. I'm guessing that we'll have to stop logging and write this in. At least we're not getting our data logging error. But the scaling was totally wrong. We're reading -20.8 kPa. And we may have to manually set that up. Okay, that's better. Now we're at 98.57 kPa. Close, that's a lot closer. As you see, we're a little bit off on our pressure ratio on barometric, but we're still getting this P1228. That's crazy. I'll have to do some more digging in that. But okay, so we can move down here. We don't care about this stuff. Speed, density, correction, cylinder charge temperature. And then, okay, that's why we're getting blank readings on our lambda sensors, and why we're not getting errors on that is because we have to be running before it even tries to read the lambda system. So, good to know. Yep. And at this point in time, we can come in here and we can look at our sensor readings. And so barometric pressure, we're 1.28 kPa off. We can come in here and adjust our offset for barometric pressure, 1.28. So if we're 429, let's go negative 41.12 or something. So changing that is not changing anything on the fly. It's showing up as pink. We have to write that in. I was wondering what things we would be able to tune live. I don't know. I'm learning with you guys at the same time. Why is that acting like it didn't take that change? 4.1, 41.12. Logging is still 1.28. Live tuning is enabled. Should be just taking, I don't know. This is weird, weird. I wonder if we jack with the manifold pressures. Zero that out. Make a difference? Nope. If I start recording? Okay, okay. So gotta be recording. Control Z to undo that. 98.59. Make that -2. 99.89. So there you can see that it changed it on the fly. But I wonder why the barometric pressure is not working. -38. It's like the barometric pressure units are not updating. That's weird. So we'll keep that as it is. Let's take a look at our fueling setup. This is just our base. There's injector dead time. If we come up here and click the arrow, you can see that we can go through and look at all this stuff. This is a setup to setup. So this is your flow rate chart that you would copy your injector data in at. You got flex fuel stoic table here. And 1465 is our target. That's fine. I'm going to go ahead and remove this tab because I shouldn't need to change anything on that since we're using all LS3 stuff. Look at our NOx setup. Shouldn't need to change anything in our NOx setup. Those are stock also. So I'll delete that for now. And you can always go back in and come under layout and add these back in. You have to be offline, but now, knock control tuning, this is one we'll leave up because we may need to do some adjustments on the knock sensor threshold for the cylinders. And you can see over here, here's our knock retard limit is set to 3. What else we've got? In PE, it can go a little bit higher, up to 6. You know, it's a nice thing, we've got good values, and then our recovery rate. And then over here is our individual cylinder threshold values, what you're used to seeing whenever you're adjusting it in the tune. So we'll leave that up. Ignition setup. This is just dwell time modifier. You can see we've got ignition 1 through 8 enabled. We can go ahead and delete this tab. Closed loop tuning we'll want to keep running. Obviously, we've got a lot of stuff missing in here because we don't have the sensors hooked up. And then airflow tuning. This is our VE table. You can see that we don't have flex fuel VE since it's not turned on. It's funny that we do have mass airflow coefficients and scaled endpoints, even though we told it we're not using a mass airflow. So it doesn't remove those tables, but this is our primary. We're fine there. It's just like airflow calculation, speed density, hybrid. So we'll leave this in speed density because that's the only one that we're running off of. And then you have multiple maps that we can look at. We're going to deal with just one map. That's more advanced stuff that we can talk about later on. We've got our enrichment, our PE. Shouldn't have to change anything from the get-go. We've got individual cylinder fuel correction underneath here. It's under enrichment lambda. Okay. Here you can see our manifold pressure versus EQ ratio, and up to 1 bar, 0.8, we can probably come in later and make this 0.85. We don't need to be going to 0.8 on a naturally aspirated setup. But as I said, we're not trying to necessarily mess with that. We're just reviewing what we need. Kind of get this ready for a first start mode. Ignition, tuning, this is our base spark tables. So we got base ignition. And see, there's a bunch of stuff here that we don't necessarily need to get into, but we can take a look at our idle ignition angle, idle electronic throttle control. Here's our throttle request, so we can adjust our throttle ramp, idle set point range. What else we've got? Park idle set point, idle ignition, startup idle airflow. So that might be stuff that we have to look at is like startup airflow. Limiter setups, we can double check these real quick. Here's our RPM. Hard limiter, engine speed. Oh, that's the hysteresis. So that's how far it has to come back underneath 50 to turn the cutoff. So we've got 68 or 6,500 RPM limit up there. And then here's our DFCO stuff. Soft limiter, which we shouldn't get into the soft limiter because our hard limiter is already at 68. Then our DTC list. Barometric okay, so why is this active though? Barometric pressure maximum. Let's look at our code again. Read DTCs, 1228. And if you mouse over this and let your icon stay there, it'll tell you what it is, 1229, 2229, 1228, that's the one that we're getting. We've got this, you know what, negative 100. No, I want that to be negative 100. Will it let me make it? No. That falls outside the range, but that should not be showing up. I wish in this section, like we've got a bunch of yeses and nos, I wish that the yeses and nos had different colors to differentiate them. So draw yourself like to statuses, like if you've got DCs, like DTCs active, highlight these. Make it easy. Oil pressure fault. And then here's our ECU status list. Battery load dump status okay. H-bridge 1 status okay. Yes means everything is normal, low means there's an error. And the H-bridge status, the high bridge, I mean, that should be the throttle body, but I hear the throttle body. Then we've got like an idle air control valve, EF1 status okay, no, but EF2 status is okay. This is drive-by-wire, so why would that have idle air control errors? So that's something we'll have to look closer at as we get into it, because that's kind of funky. Automatic throttle, drive-by-wire. Oh, this is probably something we should have done. Make sure the engine is off and the ignition is on. Press the start button to start the automatic calibration. And so we got drive-by-wire, electronic throttle, auto calibration. In case you weren't following along, this is under ECU, and this is something that you always do, first step kind of ordeal. So we got drive-by-wire, dual throttle body that can do automatic calibrations, then drive-by-cable or accelerator pedal. What's the difference between those two? Drive-by-wire should just do it by itself. There we go, pre-check successful. We may have to go push the pedal, obviously. Maybe that's what the acceleration pedal portion of this is then, why they have it separate. Because it's kind of confusing that it says drive-by-wire has an auto calibration, but acceleration pedal, as I said, we should have to get in the car and push the pedal a few times to link that out. But, you know, this is just part of the process. If we can get this portion kind of knocked out, we'll be just one. Okay, there we go. Done. Save the tune and write it to the ECU. After jack, check throttle or pedal response. But we still need to do the pedal. So let's just go ahead and save it. So we can save this. Yes, save the current tune. And write it. Just making sure we're being safe here. When in doubt, just write the tune back in. So we should have good throttle body calibration. Then we need to do the pedal. Okay, reconnecting. I don't even know if I got the right pedal. I think I used an LS3 pedal. So we'll come back in under ECU and acceleration pedal. Press the accelerator pedal to the end and then press the next button. Keep it pressed. Okay, so I'm gonna have to put this in the car. You guys can still see the screen, so I'm not too concerned about you seeing me. I just want you to see what the screen does. Okay. And I'll talk through this portion. Okay, press the accelerator pedal to the end and press the next button. Let me get wires and stuff out of the way and I'll just hop in the car so I can do this with my foot. Okay, pedals all the way down. Next, capturing the data. Lift your foot, release the pedal, press next. And I can hear the throttle bottle moving. Done. Save the tune and write it to the ECU. Okay, so we'll disconnect our live tuning. Stop our scanning. Save our tune. Okay, so we've saved those values. And write it to the ECU. Okay. And so what we just did there is so there's a couple things that go on in the background. One of them being that we cycled the throttle full open, full close, find the limits and things for idle air control. Well, there is no idle IACs. There is all throttle body stuff. But we find the limits there and get those readings, and so it knows at this voltage we're full open, at this voltage we're full close, etc. Then we do the same thing on the accelerator pedal, and it tells you to push it all the way to the floor. By pushing it all the way to the floor, it finds the highest voltage that thing is going to output and sets that to 100%. That way it ties back to the throttle to give it 100% throttle. Makes sense, right? Okay. So, what DTCs we got? I want you gone, P1228. How do I, listen, P1228, we are staying here until I can figure out how to clear this DTC. I just don't want this DTC involved at all. Why can't I just turn it off? 1228 barometric pressure sensor DTC amendment. Barometric pressure sensors values below this threshold set to P1228. And we know for a fact barometric pressure is reading 10128. It's got to be a glitch in the software. So that's just got to be something that they need to fix in the software where that's triggering that DTC regardless. So. But I mean, at this point in time, I don't think there's really anything else for us to do. We've gone through first drive-by-wire, accelerator positions fitted, barometric sensor, yes. Mass airflow, no. We don't have to worry about our mass airflow meter, so we could even close this sub window to clean this up. This one, as I said, we'll have to come back to this and this. Oh, that's okay. Here we go. Here's our raw map sensor. Here's our voltage. But it's showing here that we do have faults on this. Okay. Oh, I see what's going on. Look at our barometric pressure sensor. Our baro is reading 14.69, 14.7 atmospheric. Why is the raw reading 295? Our sensor voltage is 0.33. That is an issue. So that is why. 1 volt, something is totally out of whack here. Okay, I feel better about now. Fuel pump, our prime times, we'll leave that on there. I haven't got that fuel pump wired up yet because I don't have the fuel system done. We got our fan temperature thresholds. Okay, let's see if we can figure this thing out, especially since we got the barometric pressure sensor right here. And this is a 30 PSI transmitter. That's why. So unhook it. Okay. Sensor voltage 498. Flat line. Okay. Then 0.35. So let's do this. We'll go offline. Let's see if we can get this figured out because this is interesting. I'm going to come back into our setup wizard here and find my barometric pressure is not even underneath there. So we'll just have to go, yes, close this. We'll have to go into sensor setup, find our barometric pressure. I want to change the units to PSI just to help me out here. Okay. And we'll try and kind of calculate this. Let me see if I can find, okay, here's the pressure sensor that I'm using. See if there's any data on here. So 0.5 to 4.5 linear voltage output, 0 PSI outputs 0.5 volts. 15 outputs 2.5 volts. Now, granted, this is absolute, right? So 0 is atmospheric. So that may be part of the problem. But we should be able to get a scale here. Let's open up the calculator. And we're at 0.5, so 4 volts is our sweep range. Clear this, 30 PSI divided by 4 means each volt is 7.5. So our slope should be around 7.5. And then our offset should be half of that times 0.2 or 0.5. Come on now. So 375 should be our offset. Whether it needs to be positive or negative, I don't know. I'm going to try positive. If we think about it, we can probably figure it out. 3.75. So we gotta be, screw it, let's just write it in, see what happens. Okay, actually no, I want to leave that on. Hey, barometric pressure DTC went away. Yeah, buddy. Okay. Doesn't mean it's reading right. Barometric pressure. Yeah, okay. So we're low. We're reading 6.4. We're at 0.3335, which should be below 0 technically. Here's the thing. I don't think this is the right sensor. I thought I bought one that had negative range in it for this. I thought I bought this for something else. Because technically this thing is going to be at 0. Okay. Now we're at 2.6. So negative 375 is probably what I wanted instead of positive. So if I go negative 3.75, come back over to our drive-by-wire, that's when it goes crazy. So that is, but that's right, our barometric, see, that's interesting. We're showing 300 PSI raw, though we're showing the right pressure on there, and that's where it's getting messed up. And I guarantee you, we now have that DTC. There it is. There it is. Okay. So this sensor is not going to work, which it shouldn't. I should have had, I bought one that was negative 14. This is linear 0 to 30. I need to find the other one. So yeah, 14.7, 100 kPa. We need absolute, not gauge. This is gauge. That means 0 volt or 0 PSI on this transmitter is actually 14.7, but it reports back as 0. And that means that it's built into the scale that 0 is 0.5. It should be 2 or something like that. And we should have the ability to go below 0, essentially because we want to read 14.7 as our 0 so we can go negative. So that's why we're having some scaling issues. But hey, that's why we're doing this. That's why we're hooking this up. That's why we're learning what's going on. And yeah, I think I'm going to stop for now. I've got a couple things to look at that we know about. So if we come back in here, first time DBW, we know engine coolant temp. So here, let me grab a Sharpie and we'll write this down as things to check. And by check, I mean it's just things to fix. So engine coolant temp, IAT, which is wiring, oil pressure is just not hooked up, and I'll be honest with you, oil pressure is not hooked up because it's connected to the ground that we're using. I'll get those moved to the back of the block so I can hook that up. Oil pressure sensor and barometric baro. We need a different sensor for that. So we know we got a bunch of sensor issues. IAT one is hooked up, but we're not getting back voltage off of it. In fact, we are getting back voltage. We're getting 498 volts off of it. 4.98 volts off of it. Way too high. Should, yep, IAT circuit high. So I've got to double check the wiring on that one. That one I knew from the get-go because I split the IAT out from the mass airflow sensor. If you watched the long video, I talked about that and was not paying attention to the wires that I use on the IAT. I just grabbed 2. I'm going to have to adjust some pins. Neither here nor there, but at the same time, I couldn't do that until I got to this point to figure out which pins I needed to adjust. So we're at least to that point. Everything else looks pretty good. Needs to be hooked up. I need to, okay, guys, just have to plug in the oil pressure. I have to get a new engine coolant one, and I need to find the correct barometric one. So if we come back into our DTC statuses, barometric, engine coolant, intake air temp, injector inactive lambda, that's totally fine for now, oil pressure. So those are the big ones. And then over here, I still don't know about this idle air control EF1 status, okay? I don't think that applies. That's the only thing that we've got on the ECU status list. But I just don't know if that applies because our throttle body and pedal seems to be working right. Everything else is a yes. So I may have to reach out to HP tuners and ask, hey, what's this EF1 status and why is that the only one that's not going okay? Because you see like the H-bridge status that was a no earlier, that one cleared out, and that's because we did the calibration. And then here is an all sensor reading where we can just look at raw voltages and stuff, and then raw measurements. Perfect. Oh yeah. See, our barometric pressure raw is reading 2000 kPa, which is impossible. but we're reading 0.35. We're technically below 0 because 0.5 is 0. Okay, so we're wrapped up on here, our first look at it. Hey, we knew we had a couple things that we needed to troubleshoot. We figured out what those are. We wrote them down on our windshield, so we now have a game plan to go to the next step. What follows this now? Fixing those issues, obviously, and getting the grounds in the right place. There's a couple other connectors that need to be hooked up, and then we have to get the wideband sensors underneath there. I probably have enough 4.9s floating around here to do that, but it would be a good idea just to start with brand new ones. So that is where we're at. We're so close to being able to start this from an engine standpoint. Not quite there from a transmission. And so since we're using the turbo lambic, the next video that we really get into is going to be kind of like this. Getting the turbo lambic set up, talking, and then we have to work on the integration with the CAN bus. That's going to be the big in-depth portion. And that stuff, I want to have that stuff done before we even try first crank on the motor. On top of it, we'll go through, do all new fluids. I need to get a new filter for the transmission. Actually, I'm going to put some cheap fluid in there, run it for a couple miles, let it flush, and then change all that out. Probably wouldn't hurt to go ahead and change the oil in the LS3. It's been sitting for a long time, so that's something else, you know, I want to do beforehand. There's a lot of wiring stuff to be cleaned up. I'm less worried about that. I just want to get the thing ready to start running. Oh, and then drive shaft. Got to get the drive shaft ordered. Obviously, we're not going anywhere until we get that done. But we are hooked up, communicating and configuring things. We're and this is going to be a learning process. We're learning new software. There's going to be things that are confusing at first, and as we start working through this stuff and figuring it out, it'll start to click into place, and we'll dive more into the tuning aspects of it. So, you know, listen, stick around, and if you haven't, you know, liked, subscribed, all that stuff, please go ahead and do that. If you're interested in tuning assistance, check out the Patreon. There's a link in the description as always. But you guys know the drill. I'm going to get back to it. ABT, always be tuning.